Hello and welcome back to another weekly recap video. This week we're going over inequalities, 2D and 3D shapes, lines of symmetry and rotational symmetry, reflections, and a little bit on line equations. Okay, but before we start, we need to get ourselves into the right mindset. So we're asking ourselves, what do we want to get at the end of this year? And then, how are you going to get there? Let's begin. Okay, so when we look at inequalities, we're looking at what all the possible integer values for the values of x. So integer means whole number. So we're writing down the numbers that are between -5 and -2. Because these are not underlined, okay, we've got -5, x is going to be greater than -5, but less than -2. So greater than -5 would be -4, -3, but less than -2, so it's just these two numbers. Okay, for our next one, it's going to be greater than 0, but less than or equal to 6. So greater than 0, you're going to have 1, 2, 3, 4, 5. But because this is underlined, it means we include 6. Our next one, -4 up to 3. If we see again, both of these are underlined. So that means we can include both numbers. So -4, -3, -2, -1, 0, 1, 2, and 3. Remember, you can always pause the video before I start answering them, have a go, and then go through it together with me. Again, this one's underlined, this one isn't. It means we're going to include -4, but not include 1. So -4, -3, -2, -1, and 0. 1 is not included. And here, we're going from 2 to 9, not including 2 or 9. So 3, 4, 5, 6, 7, and 8. Okay, another way of showing inequalities is on a number line. So the trick I use for this is I always start with the letter x, because we're trying to find values of x. I look which way my arrow is pointing, which is to the left, and then I write the number that the circle is above, so 4. So we're saying x is going to be less than 4. That's what this means. Small n goes to small number. So x is less than 4. If this circle is coloured in, we put a line underneath. This circle is not coloured in, so we leave it as it is. Let's look at another example. So here, I'm going to write x first. My arrow is going to the right, so it's pointing to the right. And then the number that the circle is above is 0. Okay, so I write 0. Because the circle is filled in, I put little lines underneath. Okay, another one. We're going to start with x. The arrow is going that way, so my arrow is going to go this way. Circle's filled in, so I underline it, and we're above -1. Okay, now we've got two circles, so it's slightly different now. We start with writing the number, so -5 at this end, and we're going to write 4 at this end. X is the number in between. Okay, so x is between these two. So we're going to say that x is going to be greater than -5, but smaller than 4. Neither of these circles are filled in, so that our answer is complete there. Here we go again. We've got -1, x in the middle, and 2 on the right. Okay. X is going to be greater than -1, but smaller than -2. Smaller than 2, sorry. This side is coloured in, so we need to put the or equal to line underneath. This side is empty, so we leave that as it is. Okay. -3, x, and 2. The arrows we might noticing, if you look at all the examples we had here, all the arrows are always pointing to the left, so that might be a little bit of a trick for us there. Both these are filled in, so we can put the lines underneath. Okay, x is greater than -3, but smaller than 2, inclusive. Okay, so we'll start with some shapes. We'll start talking about these quadrilaterals. So the first quadrilateral we have here, it's got 4 sides. All quadrilaterals have 4 sides. That's what it means, quadrilateral, a 4-sided shape. Okay, this has all 4 sides, which are equal, and it also has 4 right angles. And that is called, we know, a square. So here we have the next one. we've got two equal sides here and here, and also these two sides are equal. Okay, again, four right angles, we call that a rectangle. Opposite sides are equal and all the angles are 90 degrees. Third one looks a bit more complicated. We've got these arrows, which means that this side and this side are parallel with each other, and this side and this side are parallel with each other. We also have some annotations on the angles, which tells us that this angle is equal to this angle, and this angle is equal to this angle. Okay, it looks like a diamond, but the mathematical name is a rhombus. All the sides are equal length, two pairs of parallel lines, and the opposite angles are equal. This one at the top, we can see we've got parallel lines again, here and here. These two lines are the same length, these two lines are the same length. This is called a parallelogram. So the opposite sides are equal, and it's got two pairs of parallel lines. So we can see that the parallelogram is similar to a rectangle, and the rhombus is similar to the square in terms of they've both got the same amount of sides, same length, all the sides the same length on a square, all the sides the same length on a rhombus. Okay, the third one is a kite. So the adjacent sides are equal. Adjacent means next to each other. So it means that this side and this side are equal, so they're adjacent, and this side and this side are equal, they're adjacent. And also two congruent angles. That means this angle and this angle are also the same. Okay, the last one we have is a trapezium. And all a trapezium has is one pair of parallel lines here and here. So trapezium can look lots of different ways. You can have lots of different trapeziums. You can have it looking like this. It can also look like this. It can also look like this with a right angle in it. Okay, so trapezium can have several different looks. So whenever we see a regular shape, what it's saying is all the sides are therefore equal. So a regular three-sided shape is obviously called a triangle, but for a regular polygon, regular three-sided shape, it's an equilateral triangle. So three sides the same, and every internal angle 60, 60, 60. Okay. A square is four sides, so 1, 2, 3, 4. All the sides are equal, and every angle inside here are 90 degrees. So 90, 90, 90, and 90. And remember, to show a 90-degree angle, we do a little square like that. Okay, we have a five-sided pentagon, and each internal angle there is 108. So a pentagon is five sides. We have six sides. Remember what that's called? That's a hexagon. Regular hexagon, all sides the same, and each angle inside is 120. Next one, how many sides have we got? 1, 2, 3, 4, 5, 6, 7, 8. That's an octagon, 8 sides, and each internal angle is 135 degrees. Then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sides, and that is a decagon. Get this out of the way. That's 10 sides, and each internal angle is 144. So these are our regular polygons, okay? If they are not regular, that means that these numbers will not always be the same. Okay, the angles can change if they're not regular. Okay, but it's only for a regular polygon that we can be sure that these are the numbers that go with them. So regular means all sides the same, all sides equal, and all angles equal. Okay, on to triangles then, specifically into triangles. So triangles obviously three sides, three angles. If, as we can tell here by our notation, it's got two lines on each line, that means, or even one line on each line, it means that all the sides are the same, all the angles are the same, and we just looked at that, what that's called, an equilateral triangle. So an equilateral triangle has all sides equal, and the interior angles are all 60. Okay, we know what this triangle is called. Two sides are the same, we can see there. That's called an isosceles triangle. Isosceles triangles have two sides the same, and also these bottom two angles are also the same. Okay, so we can always tell. This comes up a lot. So isosceles triangles are used quite a lot in the exam because it helps us, helps the examiner realise if you know there's two there and there. So they use that quite a lot in the exam, so you know those two are the same. Okay. Next one is a scalene triangle. No sides or angles are equal. So all the angles are different and all the sides are equal. Or all sides are unequal, sorry. And last but not least, a right angle triangle. So you can have a scalene right angle triangle and you can have an isosceles right angle triangle. So what makes it a right angle triangle specifically is this here in the corner. We've got one angle, which is a right angle. Okay, and that's your 4 different types of triangle. Okay, on to 3D shapes. So 3D shapes are described in 3 ways. It has faces, and the faces are these flat sections here. Okay, so that's your faces. You have your vertices, and the vertices are the corners. So every time you see a corner, that is a vertex. But when we speak about more than one, we call them vertices. Okay, so these are our vertices. Okay, and the edges are just the lines. So whenever you see a line, these are your edges. So what we have to be careful about is that some things on a 3D shape, so some vertices, some edges, are not visible from the front. So we have to kind of imagine we've got the 3D object in front of us. And if we were to turn it round, we'd be able to count some more parts. Okay, we'll look more at that in a second. So faces are the flat parts, vertices are the corners, and the edges are the lines. So here we've got a cube. So a cube is like a 3D square. So the number of faces, we can have a guess. So we can see 3 here, but we can assume there's another one on the back, one on the left, and one at the bottom. So the number of faces is 6. Okay, if we're looking at the edges, okay, we can see these, but there's also some other edges that we can't see that are on the back of the shape. I'll try and draw that line again. It's not much better. Okay, so we can count the edges. So if we take our pen, go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. And vertices are our corners. So we've got 1, 2, 3, 4, 5, 6, 7, and 8. 8 vertices. Okay. So a cuboid, well, a cuboid is just a stretched cube. So all of the characteristics are the same. 6 faces, 12 edges, and 8 vertices. Okay, here we have a triangular prism. So it's kind of like a Toblerone box here. If we think about the faces, we've got 1, 2 we can see, but there's one on the bottom as well. If I try and draw the other lines that would be on a prism. There we go. So we've got 1, 2, 3, 4 at the bottom, and then 5 this face closest to us. There. Okay, so that would be 5 faces. And then if we talk about edges, again, you've got 1, 2, let's just mark them off actually. Got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 edges. And vertices, we've got 1, 2, 3, 4, 5, 6. So 6 vertices. Okay, a cylinder. Think about a cylinder. Faces, you've got the top. And you've got the bottom. And this flat part, or this rounded part, also counts as a face. So we've got 3 faces on a cylinder. Edges. So if you think about a Pringles tin, you've got this part around the top, and that's an edge where 2 faces meet. And you've got the bottom part here. Again, that's where the 2 faces meet at the bottom. Okay, and there's nowhere else where faces meet. This is one whole face. The middle part is just one long face. Okay, so it doesn't meet anywhere else. So although it looks like we've got lines here and here, they actually, in real life, they don't exist, do they? So the edges of a cylinder is just 2. And vertices, if you think about it, can you see any corners there? No. Okay, a square-based pyramid. So think about it, we've got a square on the bottom, and then 4 triangles, which meet at the top. So we've got 5 faces, 4 triangles in the square at the bottom. The edges, again, draw them on. Got 1, 2, 3, 4, 5, 6, 7, but there's one hidden one. So you see where these 2 lines meet up here? There's another one that will come up to the top. So we're looking at 8 edges, and vertices, again, there are corners. So we've got 1, 2, 3, 4, and as I said, we've got this hidden corner back here. So we've got 5 vertices, 5 corners, 5 points. Okay, so there's everything sort of in a bite-sized chunk about 3D shapes you need to know. So remember, we didn't mention cone. That's like, a traffic cone or an ice cream cone. A sphere is like a ball. A tetrahedron is a pyramid with a triangle on the bottom. Okay. Okay, then lines of symmetry. A line of symmetry splits a shape up, so you could fold it, basically, and it's the same on both sides. So a line that separates a shape on both sides. So for a square, you can have a line that goes across like this, and you could fold it, and it would be the same there and there, here and there. You could have a line there, so you could fold it left to right, and it would be the same. You can also have a line of symmetry on a square from corner to corner, so you could fold it that way, and the same again from corner to corner there, and that will give you your 4 lines of symmetry. There's 4 ways you can fold a square so it's equal on both sides. So for a rectangle, we have a line of symmetry that goes down the middle like this. Again, we could fold this over to there, and we'd have the same shape, and it would fit perfectly over itself. You have a line of symmetry from left to right. Again, we could fold over this line, and everything would match up. There will be anything overlaps. Be careful, because you cannot have a line of symmetry on a rectangle that goes diagonal. If I folded this corner along this line, then I'd end up with some overlap down here, and the same if I folded out there. So there are no diagonals on a rectangle. It just has 2 lines of symmetry. Okay, a parallelogram. So this is an important one. This is one that they use in the exam quite a lot. When they're talking about parallelograms, they will say, how many lines of symmetry does it have? And when you first glance at it, you think, well, maybe there's one here. If I folded that along there. But remember, or what we might not know, is again, like a rectangle, this would end up overlapping down here. Okay, so there's not one down, and there's not one from left to right or right to left. So the trick one here is a parallelogram has no lines of symmetry. There's no lines of symmetry on a parallelogram. Okay, so that's something you have to remember, because that comes up in the exam occasionally. Okay, an equilateral triangle. So I'm being specific about an equilateral triangle. An equilateral triangle has 3 lines of symmetry. So it has one straight down, like that. It also has one from that corner through the middle of that, and also one from this corner to the middle of that line. Okay, so an equilateral triangle would have 3 lines of symmetry. Not all triangles do. For example, if you had an isosceles triangle, okay, that would only have 1 line of symmetry, going straight up like that. Okay, so an equilateral triangle has 3 lines of symmetry. Other triangles, you just have to sort of draw them on and see if that works. An isosceles has 1. Okay, rotational symmetry, and that is how many times a shape fits over itself as you turn it through 360 degrees. If we demonstrate that, here we've got a square, and you can see it moves, it can turn. But if we put another square on top of it, so what we would do, if you asked about rotational symmetry, you would get the same shape, you would take tracing paper, you would draw the shape, and then you would turn it round. Oops, I need to paste that in. So here's my traced shape. I'll put it exactly on the top, And I'm going to turn it round, so I've got a little green mark here. That's when I know I'm going to be back at the top. But you could make a mark on your tracing paper so you know we're back to the beginning. And you turn it round and see how many times it fits on itself. So on a square, we've got 1, 2, 3, and 4 back to the beginning. Okay, so this has rotational symmetry. We say order, rotational symmetry, order 4. Okay, so in the question it might say, what is the order of rotational symmetry? And our answer is order 4. Okay, if we look at a rectangle, again, we'll copy it like you would on tracing paper. So here's our copied rectangle. And again, we're just going to turn it around. So, no, nothing yet. So when we get halfway, we get 1. And when we get back to the beginning, we've got another 1, so that's 2. So this has a rotational symmetry of order 2. Okay, a parallelogram. So it has no lines of symmetry, we discussed before, but does it have any rotational symmetry? Let's take a look. Okay, we've traced it. And we'll turn it round. So nothing yet. So 1 at halfway, and then another one when we get back. So that has rotational symmetry order of 2. I just want to look at one more before we get on to the next one. So if we have, for example, an isosceles triangle, we talked about that before. Okay, let's check this. So traced it, put it on top. Keep your pen in the middle of the shape so it fits. And as you turn it round, nothing yet. No, not even halfway. Back to the beginning. So you can either say this has order of rotational symmetry 0 or 1. I usually say 1 because it goes back to itself once when it gets back to the beginning. But you can say 0 or 1. Okay, a regular pentagon. Remember we're saying regular. So when it's regular, it means all sides are the same and all the angles are the same. So if we turn this round, it should, fortunately, it's just a little bit off. So that's 1, 2, 3, 4, and then back to the beginning, 5. Okay, so any regular shape, its rotational symmetry is equal to the number of sides. So for a regular shape, 5 sides equals order 5 rotational symmetry. Regular shapes only. Okay, we'll have a quick look at reflection. So there's a couple of ways of doing reflections. The easiest way I do it, again, use trace paper. So you trace, this is my tracing paper here. I've traced the shape, so I would trace my shape, just going over it roughly with my tracing paper, with my pen. Just go over my shape, not as rough as that. Okay, and I would also trace the line. Okay, so you also need to trace your mirror line. Once you've done that, all you want to do is flip your tracing paper over. And there it is. Once you flip your tracing paper over, make sure that your line is on top of the line you drew. So make sure that line is in the same place. And if you flip your tracing paper over, it gives us our shape there on the other side in exactly the right face. Okay, if you haven't got any tracing paper, what we can do is count the squares. So from here to our mirror line is 2. So we'd count away here 2. From here, we've got 1, 2, 3, 4. So 1, 2, 3, 4. Count away. Okay, and join them as you go. From here, we've got 1, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, we can see the shape starting to take shape. And then once you've got an idea of what the shape's going to look like, you can start just drawing the shape as it's there. So the shape should be facing itself. Okay, it shouldn't be the same direction. It's a mirror image, so it's kind of the opposite of what it looks like. Okay. So again, if you wanted to, if you can, trace the shape. So you trace it down. Am I doing blue on blue? Yes. Trace it down using your tracing paper. And remember, trace the line as well. And this works for diagonal lines as well. It really works well. Okay, so make sure you trace the line. And then you're just going to flip the tracing paper, keeping the line in the same place. And there we go. That would be on top there. And we would just trace it over. Just draw the shape where it is. Okay, so the tracing paper method is the easiest, and it works for any kind of reflection. So if you can use the tracing paper, you will have it in the exam. If you haven't, ask. But make sure you put the line on top of the other line. So that's your tracing paper way of reflecting. Of course, you can count the squares again. So you'd have 2 there, and then 2 down here, 2 down here, 5 there, 5 to there, and then you just start joining the points up as you go. Okay, equations of lines. So sometimes in the exam, it might ask you to do a reflection, but also might say in the line x equals something or y equals something. So here we're just going to look at what it means when we're talking about this. So there's 2 things we have to remember. First of all, we have to remember the x and the y. So this is the x-axis. This is the y-axis. So if it's going through the x-axis, if it's cutting through this line, it's going to be called x equals. If it's cutting through the y-axis, it's going to be called y equals. So we can see that this line is going through the x-axis, and it's going at the number minus 2. So the name of this line is x equals minus 2. Okay, this line, remember we'll put y here and x here. So it's going through the y-axis. So y equals, and it's going through it at 2. So y equals 2. This one, again, it's going through the y-axis. So it's y equals, and it's going through the y-axis at minus 2. And we've got this one, it's going through the x-axis. So write x, and it equals 2. It's going through the x-axis at 2. Okay, that's it for another week. I hope you found this useful and hopefully get you back on track or give you a little bit of a boost of confidence for the work that we've done last week. Obviously, we need to ask ourselves before we leave, what do we want to get at the end of the year? And obviously, that's just a better grade. We just want to keep improving all the time. And we're going to get there by working hard, being dedicated to the subject, attending all our classes, and making sure we're working hard in those lessons as hard as we can. Okay, I'll talk to you next week.